Welcome to a new test and teardown video. This time it's something really big. I'm sorry if I'm shaking, but it's because I'm laughing a little bit. This one is a Schomandl FD1 and the FDM1 converter. So the bottom part here is a frequency mixer converter. FDM1, and the top part, the FD1, is a frequency meter. It is not only tube based. I think we'll find about 20 tubes in here, but you will also find integrated circuits and transistors and everything possible. So there's a little magic eye in there. It is, as you can see, really big, 26 by 26 centimeters, and then 56 centimeter the height. Weight is 23.4 kilos, including the converter. And I think we got power supplies in both of the units. I will show the back in a second. Oh yeah, look at that. It covers 900 megahertz, so 30 to 900 megahertz. And then by using the converter, you get 0 to 30 megahertz. So that is the idea. That was definitely something in 1965. This unit here exists in a few different versions, and I think maybe this reveals the different variations. This 38 maybe. Okay, so it's from München. And here's my FD1. We got the different informations here. So this is, I think, the divided output from the crystal oscillator, so we can verify the crystal oscillator is working. Mains goes in here, and then you can turn on and off the converter alone if you want to. And I believe this is just a looped input that goes to this one. So you're not using two connectors. And I'm, again, super happy we are using a modern IEC connector. You'll also find this model with the older and more weird connectors. There's a built-in loudspeaker, so you can hear all the different beats when you're beating with the input. And this is how this one works with mixers and oscillators and filters and all that kind of stuff. It was quite easy to remove the rear panel. And it is, of course, a sight. It is so beautiful. I should probably rotate this unit and show it in greater detail. This is the right side of the unit with the different frequency adjustments and all this mechanics here. It just moves super smooth. I don't know what this is. There's something hanging. Is that a little springy part? But this mechanic just moves so smooth. And the reason why we got the different sections here, that's because we got different harmonic generators and mixers. And the tubes are all nicely in those. Damn it, I will try and see if I can get some of these out later. They're maybe screwed in or locked in, but there is a little special. What is that doing in there? Quite a lot of tubes. I'm a little bit worried about that. So, what is that? In here we got, so that will be some trimmers called SP. Yeah, There's an inductor in here where we can trim something. That is what it is. Very good solid mechanical construction. So thick steel. Here's the left side of the unit with the readout tube. EM something. Probably some filter chokes for the different high voltage filters. And as you can see here, we got some different wires hanging around here. And now I remember why I got this super cheap at the last flea market. There was a note on top of this one saying defect. And yeah, so some skilled radio amateur gave up on this one. So that means I might as well just give up real fast. I'm not going to repair this or get this up and running or anything. But we can definitely open and inspect and enjoy the nice and fantastic design. And I believe it's the transformers or something important here in the power supply that is blown up. And that is, of course, why we have these wires hanging all over the place here. So it's good. Of course, I don't power up old stuff with a very long history. But I already found the manual and all the documentation and some schematics and stuff. And I look so much forward to show some of the details. This is, of course, the crystal oscillator. So it's nicely shielded or isolated for temperature variations. This one contains an oven and a temperature sensor and a feedback system. Of course, the oscillator and the divider, amplifiers, even a divider IC, the 74 and 90. And there's also a power supply regulator chip. I mean, who would mix transistors and tubes and all the good things and ICs? I mean, why not just upgrade a little bit and make it nice and lightweight? Probably there's a way. Ah, yeah, look at that. The screws to get the converter off, that is done from the bottom side of the converter. So I better go and do that. That will save me quite a lot of weight. And I should probably remove the transformer as the first thing. And then we can continue the investigations. Nothing was done to try and save the weight of this unit. I mean, look at the top here is a solid aluminium casting, and the thickness is 5-7 millimeter thick all over the place. Solid as can be. And I expect all those frame things and everything in here to be just as solid. See, the bottom part here is insanely solid too. We're looking at the converter unit here. I'm trying to remove this. It's of course also tube and maybe also transistor based. And again, nothing was done to save weight. Probably even call it, let's make it as heavy as possible. So that's the standoffs holding this. I mean, they are thick and heavy. And here is the converter unit. It is, of course, super beautiful designed. I like we have a little power supply here. You can easily remove mains transformer, rectifier, inductor filter, and the capacitor for the high voltage. And there isn't any regulation or anything like that because it doesn't really matter. The level of the conversion is not super important. The frequency will, of course, be important. And that will be the filament supplies going to the different tubes. And it is, of course, a crystal oscillator. And you can easily remove the crystal and change that if you want to. So far, I didn't find any transistors or anything like that. I find a little, some diodes right there. So that's probably the mixer. There'll be a little mixer somewhere here. But this oscillator is not oven. temperature controlled or anything like that. So that means when you're using this one, you don't obtain the same kind of accuracy. But probably when you're dealing with frequencies between 0 and 30 megahertz, it's not super relevant because it's not made up to harmonics of many, many hundreds of megahertz. So, of course, it's not a big deal, right? Inside the oscillator, we can now see the variable capacitor here. And this is maybe... I don't understand exactly what that is doing because it's a crystal oscillator, right? So what is the point? By the way, the crystal is not 30, but only 20. So this is not the original crystal, right? It should be 30 megahertz. How is it going to mix 0 to 30 if, I mean, there's something wrong here. So the idea is you can reset, or you can, that is, you have the oscillator disconnected, right? And then you adjust for something 60 megahertz. Maybe the oscillator is a third harmonic oscillator. So it is maybe working anyway. I should probably just try and power this up and see if there's any kind of luck with at least the converter. I mean, then we have a little bit of powering something. I mean, so now I want to play a little bit with the converter. So what I'm doing here, I am measuring the high voltage with 1 meter, and then I will go through all the different connections to the outside world. I want to know that we have 0 volts of DC on every one of these, because I'm going to connect them to my scopes and analyzers and generators and stuff like that. So if there is a shorted capacitor somewhere in here, I might blow up my equipment. So that is a good thing to double check. So let's just plug it in here. Is only 100 volt. That is a little bit low, isn't it? It's using 20 watts. Well, so far so good. I got no DC voltage on that one. Nothing here, nothing here. So all that is perfectly fine. Oh, by the way, now you see the little neon bulb right there. So I believe this one is doing a little bit of pre-regulation for the oscillator part here. And also, the diodes here, you see the 4 diodes in a little, it looks like a bridge, but this is not exactly a bridge. This is a mixer circuit with the diodes like that. So now I'm playing a little bit with the converter, and I think it works, but output is really, really low. So there's maybe a tube here with not that much gain, but the mixer is actually working. So let's just try and demonstrate this a little bit here, looking at my spectrum analyzer. This is a 0 to 100 megahertz sweep, and that peak is 60 megahertz. And if I dial the little potentiometer here on the front panel, I can adjust the level of that one. I expect this to be adjusted for maximum. If I input a 10 megahertz signal, then we get a plus minus 10. So it is 60 plus 10, 60 minus 10. So that will be the signal that goes into the frequency meter. So yeah, the mixer works, and then I can poke with the, so maybe that is the idea. You then dial this down, so this is the lowest, and then we can play with the input level, give it some more. Oh yeah, okay, so that is the, of course, this is the idea, right? And then you have these two, and now you know that it is plus minus 10. And then, I mean, you need to be a math genius to figure out how to measure any of your frequencies. Where are you? What have you got? Because now it's gonna beat 2 times. You're gonna, hit double, right? So now I am back with the main unit. And this is, of course, the boring side, the power supply, and the oscillator. And there is a connector here that goes to the power supply. So I think this is how we do the service of this one. And this whole unit, it's divided here in the middle. And look at that, we got some screws here. So, I mean, there must be a possible way to disconnect this. And that is what I'm gonna try and do, because we wanna go and play with the crystal oscillator. That should be something. Oh, even that is a little bit odd. And also look at those pieces of aluminium. It looks a little bit like home brew. Maybe this is a very low serial number, or this is just how everything was made by hand. Well. Oh yeah, by the way, the tube shields is made of brass, and inside we got this. This is a little bit untraditional, and it holds the tube completely nicely in place. See, I took this out and it's really nice and fine. So there's no vibration. It's a completely stable tube holder. I love it. So that was quite easy to lift the power supply, or at least some of the power supply. I actually don't think this is all of the power supply, but that will be some of it. We'll look a little bit inside this thing in a second. Those little mechanical things, they of course fit through these holes. So now it all makes sense. And now we can also unscrew this little shield plate and have a look at all the oscillators and all the interesting stuff from the back. So this is the back side of the power supply. There's not a lot of funny things to see here. Maybe somebody dropped it a little bit, because I can see the aluminium is quite bent around the transformer, and that is really big and heavy. Here is the support circuits for the crystal oscillator, and we see of course they are using circuit boards as well. They're using many different traditional mounting styles, and there's a big mixture of the different technologies in this product. I mean, look at this circuit board here. This is old tech, where you put the components up like that on a standard solder pad system, and it's the same over here. Much older technology. And then let's use circuit boards. But transistors, they're so brand new, nobody knows which way to mount them. So they're mounting them the wrong way, upside down. That is a little bit funny, isn't it? And that's probably a little rectifier and a little power supply for something related to the oscillator, right? Oscillator filter, I would assume. Here is the oscillator assembly. It is not exact the same model as the schematics and documentation I found. I mean, everything is completely different, so I think I am a little bit lost trying to boot this up. But I think I maybe want to give it at least one little try, because this is all we got, right? I mean, we got some power supply and we got some, I don't know, how difficult can this be? I think the relay is for the heater. It's funny they only use one set of the contacts. So that was probably the heater resistor. That's just my guess. It says 60 Celsius here. So there's a temperature sensor in there and something like that. Yeah. Maybe we can. Yeah, yes we can. It is in a little sexy socket. I really don't want to touch this. You can get the nasty itchy. That is one of the super beautiful Siemens. And there is a thermostat in this unit. And you heat it up by 24 volts and then 60 Celsius. It's gonna be, right? And it is sealed. Both here and also here at the side with a little Siemens logo in the shield. How nice. I already released a video about the internal parts in this one. I really think this is exactly the same one. But beautiful. Beautiful, that is what it is. If only I could figure out the pin out here. I should go and consult again and have a little look. I looked again in the schematics for this unit and I tried to add some of the numbers right here and nothing lines up. This is not how it's supposed to be. This is the pin 1. Pin 1 should be the plus 14 volts. I mean, this just goes to a capacitor like that. This is not good. So I cannot power this oscillator up because it's not the right model type pinout or anything like that. This is also looking very different from the documentation I got. So I feel like we should definitely open this one and have a look. Maybe there is a way to figure out how this is done inside this one. So I think, oh yeah, let's try and open. So this is inside this temperature controller and crystal holder. So the crystal is really a big crystal. And in here, I don't know if I can take a picture of this, but in here there's this glass piece with a mercury stripe in here. So the mercury touches those 2 points. And then there's this heater here. It's in series with this heater. And this one turns on and off. There's a little contact made with mercury. And that goes out via the 2 yellow wires. And that controls an external relay that turns on and off the heater. Beautiful. So let's look inside the main unit. I realized everything here is non-magnetic and it's all made of aluminium and it's copper plated on the inside. Of course, for better shielding and much better conductivity, and everything in here looks like it's some other material, but it's not magnetic. So what the heck is all these thin sheets here made of? I don't know. It's maybe aluminium or maybe some stuff like that. Got a little bit of germanium diodes. And oh yeah, I found some really cool components. Look at that. Maybe I should just try and bend it a little bit carefully. Can you see those? Double tubed ceramic capacitors. And we got them quite a few places here as well. See? I think this is a very special type. And here, so yeah, there's so we got them a few places in this unit, and they are really rare, I would say. Those are polystyrene or some, we call them styroflex here, but there's no lock searching that up, and they look very different depending on the sizes. Here is how they normally look, the little silver ones right there. Here's a little parallel connections between 2 absolutely different capacitors. Oh yeah, about the switches. See, they are all on a line because of the look and feel of this unit. And the same with the different switches. See, again, here is a switch, and this is the main on-off switch, and they gone a long way to figure this out. So now this is a rotate, and this is not how the switch is in real life. This is a flip switch, but they made a mechanical interface here that flip the switch when you rotate. I mean, look at that. And there's one even more crazy detail here. Look at the two readouts here and here. We got the little disc that rotates, and all those switches here for this harmonic generator and the filters and all that. Those switches, they must be in those rooms. There's no other way, right? So what do? You have to make a little arm that goes down to the switch like that, because you need to have the switch here. Look where I'm holding my finger right here. So this is directly outside here if we continue this shaft, right? And if you take this readout here and put it right here, so it would have been under, then you could have had this here, and then no need for all this mechanical difficulty. But I mean, it's all about looks and feel, and they don't care about development, mechanical challenges, or anything like that. They just go all the way to solve it. That is something. So here at the right side of the unit with all the signal tubes and all that, I figured out what these are doing. So there's a little spring loader, and you can see there's a little attachment, and that is to that shaft that rotates. It couples to that brown one, and that is a friction coupling. So once you see, now I hit the end and then nothing happens. I can continue and then go back. A friction coupling and a gearbox without any friction. I mean, so when I want to tune something, see, there is no slippity sloppity. I mean, amazing idea, and it really, really works. And here is a little variable inductor. So here we go. Try and have a look here when I tune this. It moves the whole little piston in and out of that inductor, because you just needed a variable inductor for this one. And there is much more cool things to see here. All those, that will be shield boxes for variable or trimmable inductors. I just took a few of them out because I wanted to see they're all individually wound and numbered and all that kind of stuff. There's a little Faraday adjustment in the middle. But where have you seen this box before? I don't know if you're as old as I am, but this is a 35mm film canister with a little screw lid. And this was very, very, very much used in the 60s and 70s. And then they drilled a hole in the bottom here, and now it's a little coil shield. So simple to reuse stuff that is already available in a millions, gazillions of them, and they don't cost anything at all. I really love it. So I think that is all I wanted to show you guys about this fantastic instrument. Unfortunately, it was not working, but I will pack it nicely together and save it for the future. Maybe I find time and energy to repair the power supply issues. But anyway, I hope you had a little bit of fun and can enjoy the build quality when nothing was spared. Absolutely not. Wow, this is amazing and expensive. Bye bye.